This $30 pile of black sand can heat an entire house for weeks. Why aren't we using it? MIT engineers just proved a bucket of the cheapest material on Earth stores more energy than a Tesla Powerwall. And the utility industry doesn't want you to know this simple but powerful low-tech solution hiding in plain sight. Think about that for a second. Sand. The stuff kids throw at each other on a summer beach. The same material builders sweep off construction sites can keep your family warm through the worst week of January. No gas line, no pellet stove, no monthly bill from a company that raises rates every single spring. Just dark grains in a metal drum, radiating warmth like a stone oven that never goes out. For 30 years I have watched boilers, furnaces, heat pumps and radiant floors chase complexity for one reason. Complexity sells service contracts. And every winter, homeowners pay the price while the industry quietly cashes their checks. So ask yourself one honest question. Why is your heating bill still climbing higher every single year? In 4 winters, average household heating costs in cold regions have nearly doubled, while wages have barely moved. Natural gas prices swing wildly. Heating oil deliveries now cost more than a small monthly car payment. The shiny heat pumps everyone is pushing quietly stop working when outside temperature drops below -20°C. That is exactly when families need heat the most, and exactly when the pump gives up on you. And it gets worse. When the grid goes down, every one of those expensive systems goes completely silent. Modern furnaces need electricity for their control boards. Even heat pumps need it for their compressors too. A simple pellet stove usually needs an electric fan powered by the wall to push warm heat out. One ice storm, one downed line, and suddenly your expensive high-tech home is colder than outside. Meanwhile, your utility company is quietly posting record profits. They absolutely love your thermostat every single day. Every degree you turn it up is another dollar in their pocket, month after month, year after year. They designed a system where you rent your warmth forever and never actually own the ability to stay warm. But there is a forgotten material that fixes all of this, sitting under our feet for thousands of years. At the Massachusetts Institute of Technology, a small team of engineers looked at this heating problem very differently. They did not chase a new chemistry. They did not invent some exotic alloy. They asked one blunt question. What is the cheapest substance on this entire planet that can actually hold heat extremely well for hours? The answer came back almost embarrassing in its simplicity. Silica sand, the kind costing $30 a ton. Specifically, dark, iron-rich sand, the kind that looks almost pitch black when you scoop it in your hand. They built what they now call a sand thermal battery. No rare earth metals, no lithium, no cobalt, no cooling loops, no exotic membranes. Just a steel silo packed with dark sand, wrapped in thick industrial insulation, with a few simple electric heating elements buried inside, something a blacksmith from 1700s could easily understand. Masons have known this trick for centuries. A stone oven, once heated, bakes bread all day on stored warmth. Old Russian houses were built around massive brick heaters called piechka, burning wood 2 hours, radiating heat for 20. The physics has been buried in plain sight the whole time. Mid-engineers simply industrialized it, added controls. They connected it to the grid, proving a pile of dirt outperforms the priciest battery in your garage. But how does simple dirt store an entire week of household heat? That is where the real magic hides. Here's what happens inside. Cheap 3 a.m. electricity gets pushed through simple resistive coils, like in an old toaster. Those coils glow, heating the sand around them. Because sand holds enormous thermal energy, the temperature climbs and climbs. The mid-prototype reached 1,000 degrees Celsius. Hotter than lava. Hotter than the inside of a wood stove. Hotter than anything you'd want in your home. But here's the trick. That heat isn't going anywhere fast. The silo wraps in high-grade mineral wool insulation over 0.5 meter thick. behaves like a giant thermos. Sand can sit at furnace temperatures for days, losing only a few degrees. Patience stored heat, waiting quietly. When your house needs warmth, a small fan pushes cool air through channels drilled deep in the hot sand. That air comes out hot enough to run through your existing ductwork, radiators, or a simple water loop. You're essentially drawing warmth from a battery storing energy as raw temperature, not chemistry. Simple but powerful. There is no combustion, nothing burns, no flame, no exhaust, no carbon monoxide, no chimney inside the silo. There are zero moving parts inside, just a fan on the outside, which means almost nothing can ever break. This is a low-tech solution in the truest sense. Simple but powerful. Engineering that lasts 40 years without service. And now the counterintuitive part that will surprise even seasoned engineers. The cheaper and dirtier the sand, the better. Highly refined white silica, the stuff used for glass, stores less heat than dark, iron-rich sand from volcanic regions. The iron content, the thing that makes sand look black, gives it extra density and extra thermal mass. The material that costs the least, the sand rejected at the quarry, works best in a thermal battery. Let that sink in. The best fuel for this system is literally waste material nobody wants to buy. Meanwhile, lithium-ion batteries, marketed as the future of home energy, depend on mining across 3 continents. Cobalt from Central Africa, lithium from South American salt flats, nickel from Indonesia. Every cell degrades within years. Every one of those cells ends up in a landfill. Sand will still be sand in 10,000 years. Heat pumps have their own dirty little secret too. Below -15 degrees Celsius, their efficiency completely collapses. Below -20, most become expensive electric radiators, drawing enormous current for very little actual usable warmth. Sand does not care about the outside temperature. A sand battery at 800 degrees keeps radiating warmth, whether it is -5 outside or -40. The colder it gets, the more valuable stored heat becomes. So why does the HVAC industry stay quiet about this? There is no annual service contract on sand, no proprietary refrigerant to sell, no compressor to replace every 8 years, almost nothing to keep billing. The industry cannot make recurring money from a pile of sand, so they quietly pretend it does not exist. This kind of technology gets ignored in glossy brochures and quietly buried inside academic journals nobody reads. Wait until you see the efficiency numbers, because this stops sounding like a hobby and starts sounding revolutionary. MIT reported round-trip thermal efficiencies of 95%. 95%! Let that impossible number really sink in. A modern lithium battery hovers around 90% for electrical round-trip, but heat conversion loses much more. A sand battery skips that whole conversion chain entirely. Electricity in, heat out, stored, then delivered directly. Almost every single joule you put in comes back out later as usable warmth inside your home. 1 ton of sand, roughly the weight of a small car, stores about 200 kilowatt-hours of heat. That is enough to warm a well-insulated home through 3 to 5 days of hard winter weather. 2 tons carries you through a full week. 5 tons, only 3 cubic meters, handles the coldest month. Now think about where that electricity comes from. Solar panels are cheapest in bright afternoon, when demand is lowest. Utilities often pay you almost nothing for it, sometimes nothing at all. Wind farms surge hard at night. Grid operators call this stranded energy. There is more of it every year, and it goes to waste. A sand battery drinks it up, charging on the cheapest, sometimes completely free, off-peak grid power at night. Then it slowly releases that stored warmth over days, precisely when your family home needs heat the most. The cost per kilowatt-hour of stored heat lands around 1 to 3 cents. Compare that to winter bills. Compare that to any tank of heating oil. Compare that to any expensive bottle of propane gas. This is essentially free heat, drawn from moments when energy is so abundant the grid cannot use it. Now here is the DIY version. Anyone with basic tools and one weekend can actually build themselves at home. Take a standard steel drum, the kind you can find at any scrapyard for $20 flat. Line the interior with a thick layer of high-temperature ceramic wool, rated for genuinely extreme heat exposure. Then fill it with dark silica sand from a local quarry, roughly 300 solid kilograms in weight. Now bury a nichrome heating element, the same simple kind used in space heaters, deep in the center. Wrap the entire drum in more insulation, thick enough that you can touch the outside completely safely afterward. Finally, plug the coil into your regular household circuit through a cheap thermostat controller, and you're finished. That is it. That is the entire recipe. A single drum built for $200 holds overnight heat, enough to warm a small garage or well-insulated workshop through a sub-zero night with 0 moving parts inside. Scale it up to 4 drums and you can preheat the water flowing through a radiant floor system. Scale further to a small silo in the corner of a basement and you have replaced your furnace entirely. Meet and their partner labs have already scaled this exact concept far beyond a single home application. In Finland, an entire town called Kankaanpää now heats its district hot water with one giant sand battery. Roughly 100 tons of sand in a steel silo the size of a small grain elevator. It quietly warms hundreds of homes, charging from surplus wind power at night. No chimney, no smell. Residents now pay less than they did 5 years ago, and the system has run for multiple winters. Almost no maintenance beyond dusting of the electrical cabinet. No gasman, no fuel truck, nothing. Think about that. A Finnish town, one of the coldest places on Earth, heating itself with sand and wind. No permits from the gas company, no fossil hookup, no pipeline, no tank of anything flammable inside. Just a big, warm pile of dirt sitting quietly in a silo. Why aren't we all using this? Here is what it actually saves you per year, and this is where the arithmetic gets almost unfair. A family in a cold climate using natural gas or oil spends $3,000 to $4,000 every winter. In some colder regions, the winter bill is even higher, and it climbs every single year without fail. A home-scale sand battery from a DIY kit or small commercial unit costs $1,000 to $2,000. Even if you double that number for a professional install, payback happens in under 3 winters flat. Sometimes even less if you pair it with existing solar panels. The system pays for itself fast. After that, your heating is essentially free. Not cheaper, free. The only ongoing cost is small off-peak electricity, used to reheat the sand each night, and if you have any solar generation, even that becomes negligible. You are looking at a system with a 20-plus year lifespan and almost zero maintenance required at all. There are no filters, no refrigerants, no pumps that wear out. The sand itself simply does not degrade. The steel does not corrode as long as it stays dry. The insulation easily lasts many decades without issues. And this pairs beautifully with any rooftop solar panel you already own on your roof right now, today. Most solar homeowners are frustrated because their panels produce huge surges at noon, sold back to utilities at pennies. A sand battery absorbs that midday surge and stores it as heat you will actually use tonight at home. The panel that used to earn you nothing now heats your entire house. It pays for itself twice over. So why isn't every single home already using it? That question truly deserves a very honest, direct answer. Utilities cannot meter a pile of sand. Once that silo sits in your basement charging from cheap off-peak power or your own solar, they cannot reach into your wallet like they do with gas connections or monthly plans. They cannot cap your usage. They cannot charge delivery fees. They cannot shut off your warmth to renegotiate rates. This kind of independence absolutely terrifies certain business models. And business models quietly write the actual public policy. There are almost no government subsidies for a non-branded, non-patented technology like a basic sand battery today. When you install a fancy heat pump, there are often rebates. Build a sand battery, there is absolutely nothing. No tax credit, no incentive at all. No advertising campaign. Lobbyists want products with recognizable brand names attached, service contracts and shareholder value baked in. A humble pile of dirt has absolutely none of those things. Meanwhile, well-funded industry groups keep pushing complex electrified solutions, heat pumps, hybrids, smart thermostats that require monthly subscriptions. All of these generate ongoing revenue. All of them create dependence. That is exactly the business model they protect. A homeowner who owns a sand battery outright has escaped that dependence, not the customer industry wants. But the word is spreading anyway. DIY builders on small forums are quietly documenting their own homemade sand batteries. Off-grid homesteaders run entire cabins on them. Small European towns are adopting the district-scale version right now. Farmers use sand batteries to preheat greenhouses through winter. Forward-thinking builders integrate sand storage into brand-new home designs. The knowledge is out there, you just have to look past the marketing to find it for yourself. And this is only the beginning. Sand can do far more than simply heat the air in your house. In the next video, I show you the water heating twin, giving virtually free hot showers all year round. Same simple principle, the natural upgrade to what we covered today. And honestly, it might be even more impressive. If you found this useful, subscribe now so you don't miss that next breakdown when it finally drops. If you know someone building a home, remodeling a basement, or paying too much for electricity, share this. It might genuinely change how they think about heat and save them thousands of dollars over the coming winters. Want to see me build a full DIY sand battery from scratch? Every measurement, every part number? Comment below, let me know and I will make it happen. Stay warm out there and remember one simple truth. Sometimes the smartest low-tech solution has been sitting quietly under our feet